what the high quality actually means. In case of the cable production, there are many aspects which are influencing the quality, which are influencing the value of the cable. The next step is the cross-linking of the polymeric materials. Just to give you a quick introduction to what cross-linking really means, that if we increase the temperature of the polymeric materials by 10 degrees, we are reducing the lifetime by 50%.
A warm welcome, everyone. Good morning, good afternoon, good evening, wherever you are. Welcome to this webinar about solar cables. Solar cables, interesting topic. An outsider would probably say, all these solar cables, they pretty much look the same. What a simple and insignificant component. And you guys, you are nitpicking to dedicate a whole webinar about this topic. However, I guess many industry insiders, they know better. And from the number of PV experts joining today, there seems to be a real interest in the topic of solar cables. Today we have over 220 people joining from 38 different countries. A pleasure to have you all here and welcome to the webinar. And today we have a great guest speaker. His name is Jan Masny from company Studer Cables. Jan, thank you for joining and a warm welcome to the webinar.
Good morning and thank you for the invitation.
Well, that's our pleasure, Jan. Let me introduce you first. So, Jan, you have tremendous experience in the PV industry. You're nearly 20 years in the industry, so you could say you're a solar veteran. Previously, you worked for Japanese company Onamba for over 10 years, specialized in PV components. Then you worked for Leoni, and since 2021 for Studer Cables. You're based in Switzerland. Studer is a company that has a very strong focus on cables since 2005, and they actually manufacture in Switzerland. You are the head of the business segment of solar, and also the sales director for APAC, UK, and Turkey. You're certainly one of the quality thought leaders in the industry, and it's a real honor to have you here on the webinar. Thanks again for joining.
Thank you so much for the invitation.
Then also presenting today is our CTO, Niklas Weimar. Many of you, of course, know him if you joined the previous webinar. Niklas, he's always working on new technologies for Sinovoltaics, and for instance, he's been in charge previously for developing our AI-driven electroluminescence imaging software, which allows us to perform 100% inspections at the factories. And nowadays, I know he's working on a new data insights platform for our clients. And without a doubt, you will hear more about this later this year. And for those who don't know me, my name is Driekus de Rooij. I'm the Managing Director at Sinovoltaics. And just like Niklas, I'm based out of beautiful Hong Kong. My main focus nowadays at Sinovoltaics is the expansion of the company, and we're actually currently building a team in the United States to serve our clients in the US better. A few words about the agenda. So the webinar is split in two parts. First, Niklas, you will give an introduction about PV cable quality risk management and explain what to pay attention to when purchasing PV cables. So regardless if you're buying your cables from China, Vietnam, India, Turkey, Europe, or USA, these are some recommendations that can be useful to be sure you're buying quality product. And after, our guest speaker, Jan, he will take over and he will speak about the tricks and traps around solar cables. And in particular, he will zoom in on the different compounds, their properties, for instance, what heat does to polymers. We'll talk about product standards and a few more things. This webinar, we aim at approximately 45 minutes, could be a little bit longer. Whenever you have a question, please type it here in the chat box. So it's the chat box, you can type your question. We see those questions and we're going to be answering as many questions as possible. A few words about Sinovoltaics. Sinovoltaics is mostly known for performing quality inspections and audits at the factories here in Asia. Our focus is helping developers of utility scale solar and battery energy storage projects to ensure the performance. You could say we're a purpose-driven company. We see it as our mission to inform our community about the latest technologies and about the risks that are there when developing solar and battery energy storage projects. And therefore, solar cables is obviously part of this. In the coming years, it's our objective to be a real partner for our clients and to ensure the performance of over 100 gigawatt of solar and battery energy storage projects. So far, we have a track record of around 16 gigawatts, so we have plenty of work ahead of us. We specialize in all the components that are being used in large-scale solar battery energy storage projects. So the majority is still PV modules. However, we also focus and have dedicated engineers to ensure the quality of inverters, transformers, mounts, trackers, anything related to floating solar, robotic cleaning machines, anything related to battery energy storage. And of course, this also includes solar cables. So let us dive into this topic. And Niklas, please go ahead and start the session about solar cable risk management.
Thank you, Drickus, for your introduction, and also from my side, webinar cables. Yeah, just as Drickus already mentioned, indeed, we a topic today that in many cases does not come up directly in everyone's mind when talking about solar power plants and related quality risks. So solar, our Sinovoltaics, or our PV and battery energy storage quality management or quality risk management services and decade-long expertise, they go beyond the big ticket equipments like modules, inverters, and containerized BESS systems, but also to the critical balance of systems or BOS components such as PV cables. And today, drawing basically from our team's extensive track record in PV cable quality assurance and also technical advice manufacturers regarding quality management, system setup and testing procedure development. So in this introductory part of, I will speak about the key quality requirements for PV cables, common PV cable quality tests, quality risk, these tests basically. So topic of PV cable quality, it is important to understand that PV cable from standard power cables and relatively a fairly new addition to the industry portfolio of cables used in diverse industrial and commercial and retail applications. So in connection with the interconnecting application in solar PV power plants, and therefore with a lifespan of 25 and more years in mind, PV cables generally need to meet a range of very stringent design criteria that in particular address outdoor stress conditions. And these include UV light resistance, being acid and base proof, moisture and extreme temperature, understanding of mechanical stress forces such as wind vibrations or compression, bending, and also biological factors stemming from rodents and fungi. And aside from making sure that a PV cable has been stress tested to the required regional and international quality standards, of which there are quite many, and with EN 506 and UL 4703 being among the most prominent ones, probably, there is a range of quality tests that should be implemented during mass production, so to ensure that the cables shipped consistently meet the stringent quality requirements. So let us have a quick look at the common, basically mass production quality tests at the factory and part of our cable quality assurance scope of work. One of the common and important tests is the conductor resistance test in line with the applicable cable cross-section. So at a given temperature section, the resistance of the conductor, which is usually made either of aluminum or tin, copper, they need to be meet a certain value. If resistance is too high, then simply speaking, and in line with Ohm's law, there is a higher impedance on the current flow, and therefore there is less electrically conductive, and they're less electrically conductive, and there's also transmission losses. So it also means there's more heat. And this is one of the quality issues our team encounters with bad quality workmanship at cable factories. Another and important test where our team also sometimes comes across failures is the tensile strength test, which is conducted on the insulation and jacket, as well as the respectively. And this test is to ascertain the compliance to its corresponding maximum stress thresholds. Basically, with this test, we measure the maximum stress a cable or cable materials can withstand before they fail, or better, for example, stress they're exposed to during installation or its operational life. Tensile strength indicated normally in Newton per square millimeter or megapascals, and breaking elongation, they vary for different materials. Then, in line with ascertaining material property compliance, and another common test done at the factories involves the measurement of thickness of the insulation layer between jacket and conductor. So they're both manual and also more advanced and precise computer-linked microscope testing devices with which the compliance of these minimum thresholds of insulation layer thickness can be measured. Then there are other important tests that I'd like to quickly introduce here. So one is the dielectric to confirm that the cable meets certain minimum electric strength values and see if it can endure actually high voltages without the breakdown. Also climatic stress test involving low, high temperature and humidity stress test in specific cable climate chambers are used to cross-validate the physical and performance properties of mass-produced cables according to the applicable design requirements. PV cables play an important role in the overall performance of a PV power plant, and quality deficiencies and failures can trigger enormous losses to a PV power plant, I would say highly disproportionate to the actual costs. So you can see here for some of the common quality defects Sinovoltaics quality engineers has found basically during PV quality inspections. Some are as simplistic as marking issues, as you can see in that example image below, and some are even more serious, like poor tensile strength and excessive conductor resistance. With this brief introduction on PV quality or PV cable quality assurance, I'd like to pass the word on to Jan Masny. Jan? The microphone is all yours.
So thank you very much again for the introduction and the nice overview of your tasks, and let me to jump into the topic right away. So welcome again, and let's talk about quality. If we imagine a new car, new watch, then we frequently have the tendency to link the high quality to luxury. But luxury is an emotional status, and everyone has a different understanding of luxury. For someone, Mercedes can be a precise, hardcore limousine. For others, it might be just a snobbish and overpriced car. Nevertheless, even by the things like the cars, the sound of the brand is only some sort of a secondary effect. If we talk about high quality, we primarily see in the background the selection of the best materials. We see precise workmanship, and of course, in most cases, also the superior customer service. But with PV, the things are a little bit different. I hope we can agree that the sound of the brand of a module maker, inverter maker, or any other component does not initiate as much emotions to us as the car makers do. But it is not even necessary, because the quality in PV is a totally different story. Quality in PV shall be understood as a safety and long-term reliability. And do you really believe that you are getting that one? I have visited so far hundreds of installations with my colleagues, and we frequently discuss how big portion of the installations are really working perfectly, how big portion of them are showing any sort of deviations. And typically we come up with a result of anywhere between 30 to 60% of deviating installations. And this sounds as a very high number. The span is quite big, because the question is how we define what is quality and what's not. But going back to the cars, imagine the 30 to 60% of the cars being sold on the market would suffer with some sort of a deviations. That would be a really apocalyptic scenario on the market and on the roads, of course. And imagine you are certainly not driving the car for 20, 30 years like you run your PV investment. So to summarize this, the high quality in PV is just about anything, but not a luxury. Now, let's take a look what the high quality actually means. In case of the cable production, there are many aspects which are influencing the quality, which are influencing the value of the cable. And today I would like to focus on the three very critical ones, in my opinion, and that's the plastic compounds and the processing, the E-beam cross-linking, and the certification. So if we should talk about the plastics, basically, if you take polymeric materials or any sort of plastics being produced or being used in the PV industry, you have basically two options. Some of the manufacturers, they buy commercially available compounds, which certainly there is nothing against that. But the problem is that the commercially available compounds typically do not meet 100% the requirements for the, let's say, physical and chemical properties of which are related to the PV standards. That means you are always on some sort of a compromising level. In our case, we manufacture the compounds on our own, and that helps us, first of all, to control the quality of the compounds, but also, and this is the primary point, it gives us the chance to prepare the recipe exactly based on the requirements which are given by the standards. So we make a compound which is perfectly matching to what is the compound going to be used for. The next step is the cross-linking of the polymeric materials. Just to give you a quick introduction to what cross-linking really means. If you have the polymeric materials, you need to bond the polymers together to create a long chain in order to maintain the flexibility and elasticity of the material stable for a long time. And you basically have two options how to do it. One is the chemical cross-linking, which is basically nothing else than the chemical additives added in the manufacturing process, in case of the cable into the extrusion process, and the chemical additives will cross-link the material, cross-link the polymers. The negative part of this is that the chemicals inside of the cable will remain there for the whole time. This means the cross-linking process continues over the time and creates more and more bonds in between the polymeric structures, which in a certain moment turns from an advantage to a disadvantage. That means the cables or the polymers are becoming more brittle, more fragile. And if you would take a cable which would be a couple decades old, then it can be observed the micro cracks and all kinds of aging failures happening with the cable. On the other hand, if you apply the electron beam cross-linking, you are affecting the polymeric structure for a specified time in a specified strength and performance. And once the process is done, it's finished. And the elasticity or the physical properties of the cable will remain unchanged for the whole lifetime of the installation. So you see a significant difference, and electron beam cross-linking makes a huge difference. What is also very important, and if you were not making any notes until now, then I would suggest you to do so at this moment, because there is a Arrhenius law applied to the polymeric materials. And this Arrhenius law says that if we increase the temperature of the polymeric materials by 10 degrees, we are reducing the lifetime by 50%. This is really important. I would like to mention that again. 10 degrees up means 50% of the lifetime goes down. In the polymeric materials which we use, the typical Arrhenius curves shows us that by the temperature of 120 degrees, the polymeric material would be able to withstand for 20,000 hours. If I would increase the temperature by 10 degrees, then immediately I drop it by 50%, means up to 10,000 hours. And this is very important because heat caused by the resistance in PV is one of the very frequent phenomenons. And I would say extended heat exposure is something what we see in PV very, very often. Now, let me get back to the very beginning again. And if we hopefully agree now on the fact that the quality in PV equals to the safety and long-term reliability, then the next question comes up. How do we define the quality? How do we define the reliability of the products? There is a whole bunch of standards, norms, and criteria which are used to define the quality in PV. But the difficulty is to understand how the standards are being created and how they are being used. So in principle, majority of the countries in the world are member countries of IEC, respectively here in Europe, EN and Sinovoltaics. And that means all the standards and norms which are adopted by these organizations should be automatically adopted by the national or the states in general. Unfortunately, I have noticed that this is not always the case, and sometimes the countries are working with some standards or local agreements which have nothing to do with PV, and that certainly brings problems to the PV industry in terms of understanding the quality. And if we would go really deeper to how to understand the standards or what is the role, because many people come to me and say a standard is only a recommendation, it's not a law. But keep in mind that if you will, or your investment will be a subject of a legal case, of a quality claim, or any sort of, let's say, hazardous situation, the very first thing which the investigation will look for is whether the components, or the parts, whether the assembly procedures were meeting the requirements of the latest standards. If you don't follow, you have a problem. Now, in order to understand what sort of role do the standards play in the quality, we have to keep in mind three major factors. One is that the standard is a global compromise. Imagine a process which is run by the team of, I don't know, 100 people. They are coming from different regions, different backgrounds, and they have different motivations. And in order to create a standard, it requires a certain level of compromise. I'm not saying the compromise needs to be necessarily bad, but a compromise means that it is not covering the extreme situations, which might certainly happen on your side. The second thing is that these standards require quite a long time to be established. If we talk about completely new standard, it can easily reach 6 or even 10, 12 years to be established. But the fact that you don't have a standard for a specific part of your application, it does not mean that the risk does not exist. The risk is there, and it is up to your own responsibility to consider the risk when you are preparing your installation. So at the end, and this is maybe another remark which you should note, following the standards does not mean that you reach the quality, the required quality. Following the standards is actually the very minimum what you should do for your quality and safety in the installation. Now, to show you some examples, I have decided to pick the floating PV. Floating PV in, let's say, mass scale has started, I don't know, 5-6 years back. And at that time, all the standards which were available, at least from the EN or Sinovoltaics perspective, were not taking into consideration that the PV will be subject of enormous dynamic load, that the PV will be a subject of permanent moisture or water exposure. So that means that the standards are not ready for that. And with few exceptions which exist, and by the way, cable is one of them, where we have some additional standards available, most of the parts of PV are still not guided by any standard. And that can bring you a lot of problems if you do not take this factor into the consideration. What sort of problems? Let's take a look. So here you have, for example, the connectors with the cables, time to time hanging in the water or dipped in the water. And here is one reminder from my side. In accordance with the specification with most of the connector makers, most of the connector warranty will be void in case of an exposure in the water for longer than 1 hour. What you see on the picture on the cable ends, this is nothing else than a discoloration as a result of heat. The heat comes from the higher resistance inside of the connectors. And what you see here is a very, very dangerous phenomenon. Second one here is installer try to protect the cables in the tubes, in the protective tubes. But if the protection doesn't work well, then the water can penetrate inside and creates a dangerous microclimate inside of the tubes. And in combination with the heat, the cables get damaged very easily, as you can see on the picture. In case of the floating PV, we have another phenomenon, which is the marine life and the vegetation and all kinds of barnacles and shells can damage not only the cables, but basically any part of the installation. And once the moisture gets inside of the cables, means to the conductors, it is only a matter of time till the moisture inside of the cable penetrates through the cable to the end equipment like the combiner boxes or inverters, and will certainly cause or initiate the corrosion process inside of the equipment. Believe me, you do not want this to be happen. Now, let's leave the floating PV and go to other examples. If we talk about the quality, 50% of the quality is determined by the planning phase. You need to decide about the right components to be used. The list of materials should be appropriate to the installation. And certainly you need to also calculate correctly all the electrical parameters which are going to be used in your installation. In this particular 3 megawatt rooftop installation, we see a trouble of insufficient arcing protection combined with the underestimated resistance capacity of the cables. In other words, the wrong cross-section of the cables has been used. The result is that the PV plant is off the operation for a long time. And by the way, replacing the cables is a very complicated and very expensive discipline at the end of the day. We are getting to the end. This is an example of a very large installation, few hundred megawatt. There is a picture of a blown up inverter, which was carrying roughly 7 megawatt of circuit for itself. And the reason here was the lousy workmanship. And this shows that besides selecting the right materials, it is crucially important to also pay attention to the way how you execute the installation, how you install, and how precise are you with your labor on the field, because you can use even the best materials in the world. If you will not install it properly, you will still see lots of issues. So the installation methods and the precision of those methods is really crucial. Here, most probably the 7 megawatt array will be out of operation for several months. And I think I don't need to explain what sort of costs and damages does it represent. So we are getting to the end, and if you were not making any notes until now, I would strongly recommend you to take a note at least of the last point. And this means the quality in PV is certainly not everything. But if you resign or if you ignore the quality, the need for the quality in PV, you will end up with nothing. That's all from my side. Thank you very much for your attention, and I hope you will be inspired for using the high quality in PV from now on.
Thank you, Jan. That was very interesting. That photo with the marine life stuck to the solar cables, that kind of impressed me. Maybe they're actually coming for the heat or something. I've never seen this before, but yeah, there were some interesting examples. Well, that brings us to the Q&A session. Everyone, if you still have some questions, please feel free to type them here in the chat box. I will just go through them, and Jan, see if you can answer them. If not, Niklas, you can also step in. Here's the first question. It says, it seems the compounds are important for the quality of the solar cables. When performing quality inspections, should the raw materials be checked as well? Who likes to answer this question?
What I can say is it is very complicated for the inspection people to somehow evaluate the raw materials. But what I assume a part of important part of the job of the inspection people is the technical due diligence of the suppliers. And this is definitely a place where you can evaluate the quality of the raw materials, where you can see how consistent or inconsistent the quality measures in the production facility, and it doesn't matter if we are talking about module, cable, or whatsoever, is. So I think the inspection of the raw materials is something which should be performed before you even finalize your bill of materials.
Right. Nick, I don't know if you'd like to add anything to this?
Yeah, I fully agree. And maybe to add to this also from our own practice or expertise, it is actually fairly uncommon actually also to do this, at least basically from a commercial point of view, like those that basically opt to QA that usually look at the quality of the final product itself. And then there's, of course, a certain faith into, of course, put into like at least, of course, high quality suppliers that also then, that well aligned, that of course the quality materials are being used. As already mentioned, so it's in more evaluating like actually by certified materials. So it's a documentary compliance review, so to say, but it's not so much common that you would like test every single compost or compound basically during the. I mean, I've yet to see that kind of requests, but it's more important actually look at the final cable than from our experience.
Correct.
So,
okay, thank you. Let's move on to the next question. This one comes from Vincent. Vincent, good to have you on. His question: what are the most important IEC standards for solar DC and AC cables that developers should demand from the EPC? Do you know this from the top of your head, or?
Okay, I would say here we need to distinguish between DC and AC, because this is actually a very important topic. The AC is typically being regulated on a national base. Each country, and sometimes even each region in a country, might have a different requirements for the AC applications or use of AC. In case of the DC side, this is what I have mentioned earlier, is a subject of the standards of IEC and EN or Senelec. Here, I would say, if you are really serious about the quality of the cables specifically, then I would recommend to follow the EN standards, EN 50618, because as I have mentioned, the IEC is some sort of a compromise. And for example, one of the major differences between EN and IEC in the cable standard is that IEC does not strictly require halogen-free cables, which is something what I believe in 21st century should be a common practice, and the EN requirements are higher than the IEC in this case. So there are more standards because the standard, even the 50618 from EN, is referring to other standards related to, for example, the laying instructions, use of the cable, etc., etc. So if somebody would be interested, feel free to get in touch with me, and I can provide you with all the list of the relevant standards to be followed.
Very good. Well, thank you, Jan. That's a very useful answer. And there were similar questions about the standards, for instance, from Jack as well, aside from Vincent. So I think this is answering that question for sure. So let us see. There's a couple more questions, actually. One moment. Okay, there's someone say that was an informative presentation. Not really a question, but just a comment. Another question here. I find this interesting as well. You mentioned heat as a risk. How about extreme cold? What temperatures are typically okay for the polymers inside a cable before the polymers inside the cable become brittle?
Okay, so the cable is certified, or the certification requires the minimum temperature of -40 degrees. I believe that this applies to all the PV equipment being used. And I would say that the PV cable, at least from our perspective, is actually not among the most critical components. I would assume if we would go to lower temperatures, let's say -50, -60, the combiner boxes, inverters, and modules itself will be in much bigger threat than the cable itself. So in other words, to answer that, the low temperature is not really a subject of any failures or deviations from the practical point of view, well, as far as I see it.
Okay, that's very good advice. Then I saw another interesting question from Ralph, which is coming up here. He's asking, how is the UV resistance defined and what guarantees can be expected? Is additional cover for sun-exposed cables necessary?
Okay, so the UV test is among the most difficult ones because the UV exposure is very difficult to somehow simulate. So in many kind of tests, which are a part of the standards, you can simulate by accelerated aging, for example, and you can somehow see what is the prediction of the material. With UV, it is quite complicated. Now, I hope I don't say a wrong number, but I believe by the EN standard, the UV exposure is 400 hours, which is literally nothing, you know. And from our perspective, the UV resistance is a very, very important factor, and we pay a lot of attention to this. So for that reason, one of the basic requirements, which I would say everybody should follow, is to make sure that your cable is going to be black. If you are using colors or any sort of pigments, then you are compromising the UV resistance. And to give you an example, PV standards in the very, very beginnings were actually inspired by, for example, the railway standards. And if you see the railway cables, they need to, the locomotives and the trains need to survive for 30, 40, 50 years. And if you would look into the train, you would see only the black cables outside of the train, which are exposed to the outdoor environment. So that means UV is a critical part for sure. If you follow the good suppliers who take the UV risk into serious consideration, you shouldn't be able to make a mistake. For our case, if we say PV is 20, 30, 35, 40 years, then our cables should definitely withstand this time frame.
Okay. Thank you for answering this. There's actually a few more. Just going through. This is actually interesting from Nicolas. What's your point of view regarding putting PV wires in tubes? I guess you're not promoting it because of the microclimate you just mentioned.
Yes, this is very true, and I see that very frequent by the installers. Sometimes they are afraid that the cables are not UV resistant enough, and they tend to protect the cables. What I would like to say here is, if you feel more confident with protecting the cable, feel free to do so. But if you decide to do so, make sure you are doing that in the right way, because if you use tubes or if you use like a closed cabinets or whatsoever, then you are only creating a microclimate inside. You are increasing the temperature. Again, we have said that increasing temperature is a big risk in general. So for me, I'm very free if you leave the cable properly fixed, but exposed to the outdoor environment. That's what the cable has been designed for.
Yeah, and then there's another question here, which is related. Someone asking, better to bury the cables or leave them exposed?
Also, very frequent topic. In general, there is a standard which says that the PV string cables shall not be buried. This is a basic law for us, and if you do not follow this, then you are facing certain risks, and I will explain the two most difficult ones. First of all, if you bury the cable, you are exposing the cable typically to 100% moisture. So in principle, you have the same environment like if you would keep the cable under the water. The second risk which you are facing is the mechanical stress. If we talk about direct burial cables, typically these are armored cables or somehow protected in the conduits. If you just lay the cable in the ground, you will have a problem with the abrasion, with the stones, with the movement of the ground, etc. And the cable is simply too thin and too fragile to withstand this kind of risk. So what I always recommend to the EPCs, try to avoid direct burial. And if you have no other option and you really need to bury the cable into the ground, make sure you protect it mechanically well, and make sure you select a cable which is more resistant to the moisture, which is definitely in the ground.
Right. Okay. Excellent. Thank you for that answer. We're almost there. Commercial question here, last one, Federico. He's saying, is there a Studer cable dealer in Southeast Asia?
Yes, we have. Southeast Asia is a wide region, so we have several of them. Two of my colleagues are representing our company in the office in Singapore and Malaysia. So if you get in touch with me and you tell me where precisely in Southeast Asia, I will guide you the right way.
Very good. Well, here another comment from one of the participants. There was an informative presentation. Well, it brings us to the end of the session. I feel like I learned a lot, actually, and especially because of the questions from the community. And there were some really good questions, and it brought a lot of value on top of the presentation. So thank you very much, Jan. It was a real pleasure having you here on, and you're a true expert in the field. And thanks for sharing your know-how. And we hope to one day see you again on another webinar in the future. And like we discussed, for sure, we'll see each other at Intersolar Europe in June in beautiful Munich. Hopefully, it's going to be some nice sunny days, like most of the years.
Usually,
personally, I look forward to it.
Right.
Yeah, usually it is. Yeah, this is how I always remember Intersolar Europe. So
yeah.
one more thing. Now that we have all people here on the community, as mentioned, Sinovoltaics is building up a team in the USA. And if any of you like to be involved, or you know excellent people that could be part of our team, please feel free to reach out. We're building a nice team to serve our clients in the USA better. And if you'd like to be involved, please reach out. Thank you all for joining the session today. We'll have more regular webinars coming up. I hope to see you during one of the upcoming webinars. And one more thing I almost forgot here, the contact details. So from Jan, feel free to reach out to him for any other questions, or whatever you'd like to ask. Thanks a lot for coming, and see you next time. Bye-bye.
Thank you. Wish everybody a nice day. Bye-bye.
Have a good day. Bye-bye.
Visit sinovoltaics.com to learn more.